Okay, kiddo. So the first thing we're going to do is we're going to start with rational exponents, which is just writing things in exponential notation. So on the first one, if I give you 7 times 7 times 7 times 7, this is the same as taking 7 and multiplying it by itself 5 times. So the exponential notation for 7 times 7 times 7 times 7 times 7 is 7 to the 5th power, right? Like that's not something super foreign to any of you. Fantastic. Another thing that we know when we talk about rational exponents is that means that we can have exponents that are fractional, so they don't necessarily have to be whole numbers. So whenever we see a fractional exponent, this is the same as taking the root of that variable, and the root we're taking is the denominator of our fraction. So if I have 1/2, that is the same as the square root of whatever I'm taking to the 1/2 power. If I have x to the 1/4, that is the same as taking the 4th root of whatever I'm taking to that 1/4 power. So whenever you have a fractional exponent, that denominator is always the root that we're taking. Similarly, whatever that numerator is the power that I'm raising my answer to. So if I give you x to the 2/3, this means I'm taking the cube root of x and then squaring it, which is the same as taking the cube root of x squared. Okay, this first way is the easiest way of doing it typically. Okay. So then I'm going to have you guys practice. What if I gave you x to the 5/7? I would like you to write that using radicals, like we did in the 2/3 problem above it. Jonah, what's the root that you just took?
I took 7 and put it on like the inside of the parentheses, like right next to
like that. Okay.
And then I put the parentheses around the equation and put the 5 root up above there.
Where's your x?
Inside the.
Okay, I just wanted to check.
Okay.
Does anybody get really, really confused when I'm talking about a fractional exponent and turning it into a radical? Did anybody not get this? Okay. So the next question you should have is, how is this useful? Right? Because nobody likes to do something if it's not super duper useful. So for instance, if I gave you four to the 3/2, and I wanted you to solve that or to simplify that, I could rewrite this as a radical, which would allow me to do one step at a time and get an answer. So for instance, this would be the square root of 4 and then cubed. Or, remember, it can go both ways. It could also be the square root of 4 cubed. Either way, it's still going to come out to the same answer. What's the square root of 4?
2.
2. And then I cube 2, and I get what?
8.
Let's check to make sure this one works out the same way. What's 4 cubed?
2.
No.
Wait, what? What were you
4
saying?
cubed, which is 4 times 4 times 4.
32.
64.
54.
I'm so smart.
And then what's the square root of 64?
8.
8. So by being able to convert between rational or fractional exponents and then radicals, I'm able to solve things that look completely unsolvable. Okay? So this is just a really good skill to have. This is something that you'll have to do on your homework, just so you are aware. Okay?
Okay.
I know, so easy, right? So I'm going to have you practice this kind of, and we're going to see how it goes. So given real numbers, I would like for you to solve these following problems. I want 81 to the 1/4 power. How would I rewrite this as a radical? Stephen.
Here we go. Let me turn my microphone on. Wouldn't you put the? Is that when you put the 81 in the square root and put the 4 on the right outside?
On the left outside, right? Because I get the 4th root of 81. Correct? Did this help me solve it at all, though?
No, not at all.
No. It helped me represent it differently, but it didn't actually help us solve it. So sometimes even rewriting it as a radical doesn't really do anything. So this is where your calculator comes in handy. I can actually put this into my calculator by using parentheses. So I would do 81, and then there's an upward arrow, which we call a caret. And then to the 1/4 in parentheses power. And then tell me what you all get.
Yeah, I don't see that caret.
Should be on the right-hand side toward the
I'm
top
on
of
my
your
phone calculator right now, so that might be why.
That might be why. There might be like a y to the x, which is the same thing. No, Devin, not true.
Oh, y to the x. Okay, I see it.
I'm just kidding, Devin, you are right.
Parentheses 1. All right.
What do we get?
3.
3!
43,046,000.
Oh my gosh.
All right, I put it in wrong or something.
Yeah, clearly. So just being able to convert something from exponential to radical and radical to exponential does not mean that it makes it easy. Does not mean that we're able to solve it that easily. It just makes it helpful most of the time. So there are times where you'll just have to put it into your calculator like we did here. Okay? Just making sure you understand that.
If we wanted to, could we just like put it in our calculator in like general?
Technically, yes, unless I say convert, in which case you have to show me you can do it.
Okay.
Another thing that we can take note of when it comes to exponential functions is if I have a function that is y equals x to the 1/n power, so that means it could be like 1/2 or 1/3 or 1/4, whatever it is. If n is an even number, so 2, 4, 6, 8, 10, 12, all those, and it's positive, okay, so it has to be a positive integer, then the domain of our function and the range of our function will be 0 to infinity. If n is odd, so if I get like 1/3 or 1/5 or 1/7 and positive, then the domain and the range will be negative infinity to infinity. That is just some helpful information to know. which then brings us into really our last little piece of notes, which is most of what your homework is. Okay? And that is using exponential rules. You did this in Algebra 2 as well, so it shouldn't be completely foreign to you. Hopefully you remember at least some of it.
I don't remember anything from Algebra 2.
Oh, wonderful. Okay. So the first rule is, if I am multiplying two variables together with their exponents, that is the same as that variable with the exponents added together. So x times a plus, x to the a times x to the b is equal to x to the a plus b. So when we multiply two terms, we add the exponents. If we divide two terms, then we subtract the exponents. If we raise an exponent to another exponent, so x to the a, all raised to the b power, then we multiply the exponents together. Devin, I'm reading what you wrote. Hold on. Yes, you do this all the time and you don't even realize that you're doing it. The next rule we have is if we have a negative exponent. For instance, if I have x to the negative a, this means that I have to take that whole term and move it to the opposite side of the fraction. Okay, so because this was in the numerator and it was a negative, when it moved to the denominator, it became a positive. The same thing applies. If I had a negative in my denominator, it would then move up to the numerator and become positive. So we just move it to the opposite side of the fraction. Our next rule is if I'm multiplying two terms together and raising them all to the a power, that is the same as raising each of them to the a power and then multiplying their answers together. The same thing, of course, applies when we're dividing. So if I'm dividing two terms and raising its entire answer to the a power, that is the same as raising them individually to the a power and then still dividing their answers. And then I have one more little nugget of wisdom to give you when it comes to exponential rules, and that is any variable raised to the 0 power is just equal to 1. And that's true for everything. Literally anything raised to the 0 power is 1. So then what we're going to do is we're going to take these rules and we're going to apply them. And that's what you're doing on majority of your homework today as well. I'll give you guys a minute to finish writing them, and then we'll do some examples.
Do you think we're going to be back in school next week?
I sure as heck hope so. I honestly have no idea. I'm not the one that makes those executive decisions. But I'm sure you're all hoping that we will be back in session as well.
Me, yes.
Yes, definitely.
Are the tests almost graded?
I honestly haven't even started them, but they should all be in by midnight tonight.
Okay.
That's the goal I have set for myself. What you don't know is that I also tested in 3 other classes last week. And I haven't touched any of those tests either. And they were 2-day tests. So I actually have 6 additional tests to grade on top of yours. I love my life. Okay, are we ready to do some problems?
You could just give everyone A pluses.
Huh?
You could just give us all A's on it.
Oh, that's really, really funny, Steven. And most definitely not happening. Okay,
Curved?
yes, your test will be curved. Let's go ahead and do some fun examples. Okay, so I have m to the fourth times n to the sixth times m to the negative 1 all over n to the fourth. Okay, so this is a practice problem when it comes to using exponential rules to simplify expressions. So when we have something like this, there's a general rule that we have to follow, and that is we simplify the numerator first, and we simplify the denominator, and then we simplify across the fraction bar, okay? So we do the top and the bottom individually first. So as I'm looking at the top, is there anything that I can put together? The m's, right, Devin. I have an m to the fourth, and I have an m to the negative 1 that are being multiplied together. Remember, when I multiply two terms together, I add their exponents. So this simplifies into m to the 4 minus 1, which is 3. The n stays because there's nothing I can combine it with in my numerator. And the n in the denominator also stays because there's nothing I can combine it with in the denominator. So now that my numerator and denominator are as simplified as they can be, I get to simplify across the fraction bar. Okay, so what do I notice that both my numerator and my denominator have?
N.
They
N.
have an n. So what I need to do is I need to decide which one of these n terms is bigger, the numerator or the denominator.
Top.
Numerator.
So which one?
Numerator.
Numerator, because it's a 6, whereas this one's a 4. The larger one stays. Okay, so since that larger one is staying, I'm going to go ahead and move this one to the top. And when I do, it becomes subtraction. So now I have in my numerator n to the 6 minus 4, which will equal 2. So now I have m cubed, n squared, and then I'm done because there's nothing else that I can combine. Anybody super confused by that?
No.
Jonah.
Okay, so let's go ahead and do another one then. Okie dokie. So in my numerator, I have the quantity a squared b cubed all squared times 2b squared over the quantity 3b taken to the fourth power times a.
Is the b inside the parentheses to the third?
Yes.
Okay.
Okay, so as I'm looking at this, we still follow the same steps that we did on the last one, which means I have to simplify my numerator first, and I have to simplify my denominator first before I can simplify across the fraction bar. So as I'm looking at that numerator, we follow the order of operations. So I look inside the parentheses first. Is there anything I can put together inside that parentheses? The answer is no, which means I have to do exponent next. This exponent has to go to each term inside that parentheses. Okay, and since it's an exponent raised to an exponent, I'm multiplying them together. So a squared becomes a to the fourth. B cubed squared becomes b to the sixth, because 3 times 2 is 6. And then times the 2b squared that's outside the parentheses. I do the same thing in the denominator. This 4 goes to each term inside of my parentheses. So I have to do 3 to the fourth. What's 3 to the fourth, everyone?
81.
81. So I get 81 and then b to the fourth times a. I am not finished simplifying my numerator because I still have b's up there that I can put together, but my denominator is ready to go, okay? In the numerator, the first thing I'm gonna do is I'm gonna take this 2 and I'm gonna put it out front just to get it out of the way. Then I have b6 and b squared. I'm multiplying those two terms together, which means I'm adding the exponents. So that becomes b to the 8th. And then over 81 b4a. My numerator is as simplified as I can go, and my denominator is as simplified as I can go, which means all I have left to do now is to simplify across the fraction bar. The first thing I want to look at is the number. Can I reduce the 2 and the 81?
Yeah.
What goes into 2 and 81?
I don't think anything actually.
Nothing. So I can't reduce that, so they're going to stay. But I have an A4 and an A. So which one of those is bigger, A4 or A?
A4.
A4, which means this A from the denominator is going to get canceled out and subtracted from the A4 in my numerator. So I'm going to have 4 minus 1 because there was a 1 exponent on the A in the denominator. The same thing is going to work with the B's. I have a B8 and I have a B4. Which one of those is bigger?
B to the 8.
B to the 8th, right? Yes, the top is bigger. So that means this B4 from the bottom is going to be subtracted from the B8 in the numerator, which leaves me with 2 over 81. I'm just going to write it as a fraction out front because it's a little bit easier, times A to the 4 minus 1, which is 3, times B to the 8 minus 4, which is 4. So I get 2 over 81 times A3B4. You also could have left this as 2A3B4 all over 81. That would have been fine as well. Either one of those are acceptable answers. Any questions on that?
No.
No. Okay. You ready to do some more?
Yes.
We're going to do one more, and I think that that will be sufficient. Okay?
Yes.
So let's go ahead and do.
Give us a hard one.
Oh, okay. Give me a second.
So
Pull
we
it
know
down
what
so you
to
can
do.
see it while I'm writing it.
Yes. I agree, Devin.
What did he say?
Something way harder than the homework, so we know what we're doing for the homework.
I'm working on it. Hold on. Okay, there you go. In the numerator, I have parentheses 4a0 b4 parentheses to the 3rd power times a to the 7th power times 3. In the denominator, I have parentheses a squared b5 parentheses to the -1 power times c7 times 2, and then that entire thing taken to the -2 power.
I have a question. What is the first? It's 4A what?
A0.
A0. B.
So you really did give us a hard one, huh?
You asked for it.
Is it gonna be this hard on the test?
Probably not. Okay, let me know when you guys have that written.
Mine's written, but it's not good.
Okay, does anybody not have it written? Hold on a second, Devin.
416.
Okay, we ready?
Yep.
There are technically a couple different ways we could start this one. I'm going to tell you the way I would start it. That -2 exponent outside, I don't want to have a negative. So the first thing I personally would do is I would flip this entire fraction over and take it to the +2 power, because that makes it a lot easier for me.
So I got to rewrite the whole thing.
Yeah. Okay, so this means my first step, I guess I'll come over here, is going to be taking everything from the denominator, putting it up in the numerator, and everything from the numerator and putting it in the denominator, because that negative means that everything needs to switch places. And then it's going to become to the +2 power. So now I'm going to have a squared b5 to the -1 times c7 times 2 in my numerator. And I'm going to have 4a0 b4 cubed times a7 times 3 in my denominator. And now it's all raised to the +2 power, because I flipped it all over, which got rid of the negative portion. And then we're going to go ahead and do what Devin said, which is to simplify inside of the smaller parentheses first, and do that smaller parentheses, and then simplify our numerator and denominator individually, and then across. So in that new numerator I have, there's nothing inside of that parentheses that I can put together. So I first need to distribute the -1 to each of those values inside the parentheses. Okay, so here's my big parentheses, my fraction bar. When I raise an exponent to an exponent, we multiply them together. So that now becomes a to the -2, b to the -5, and then the c7 and the 2 stay the same. In the denominator, I need to simplify inside my parentheses first. There's nothing I can put together, but there is something I can get rid of. What can I get rid of in that denominator parentheses? What's a to the 0 power?
1.
1. So I technically don't even have to include it, because 1 isn't going to change any of my values. So I just have 4 and b to the 4th. Nothing I can put together there. So I need to raise each of those to the 3rd power. 4 cubed is 64. B to the 4th times 3 becomes b to the 12. And then I have a7 and I have 3. And this is all squared. Remember, don't forget that exponent on the outside of the big parentheses. Now I need to simplify the numerator and the denominator individually. So is there anything in the numerator that I can put together with itself? No. So I'm just going to go ahead and rewrite it. And I'm going to put the 2 out front just because it makes it a little bit easier. Then I look to my denominator. Is there anything I can put together in my denominator?
Can you put 64 and 3?
64 and 3. So when I multiply that together, I get 192. And then I have B12 and A7. Again, nothing I can put together outside of those 2 whole numbers, which means now I can simplify across my fraction bar. The first thing I look at are my numbers. Can I reduce 2 and 192?
Yeah.
Yeah, what can I take out of both of those?
2.
2. So that means when I simplify it, when I take a 2 out of 2, it just becomes a 1. When I take a 2 out of 192, I get 96. So now in my denominator, I have a 96. Are there A's in both the numerator and the denominator?
Yeah.
Yes. Which one's bigger, numerator or denominator?
Denominator.
Denominator, because in the numerator, I have A negative 2. In the denominator, I have A 7. 7 is bigger than negative 2. So I'm going to subtract the negative 2 exponent from my numerator. Well, when I subtract a negative, that becomes positive. So then that becomes 7 plus 2, which is 9. So now I have A to the 9th in my denominator. I go ahead and I look at my B's next because I like to do alphabetical order. Do I have a B present in both my numerator and my denominator?
Yep.
Yes, my denominator is bigger because it's a 12, where my numerator is a negative 5. So I go ahead and I subtract that numerator exponent, which gives me 12 minus a negative 5, which is the same as 12 plus 5. So that becomes B17 in my denominator. Is there C present in both my numerator and my denominator?
No. Just.
No, just the numerator, so it stays. And remember, this is all being taken to the second power. So now, since my fraction is technically as simplified as it can go, I go ahead and I'm going to raise everything to the second power. Which means when I raise an exponent to an exponent, it just multiplies together. So my numerator is going to become c to the 14th power. In my calculator, I'm going to need to do 96 squared, which is 96 times 96.
9,216.
This is a really poor choice for me to use. So 9,216. A to the 9th becomes A to the 9 times 2, which is 18. And B to the 17th becomes B to the 17 times 2, which is 34. So then my simplified fraction is c to the 14 over 9,216 times a to the 18th times b to the 34th.
Well, that was interesting.
You asked for hard, I gave you hard.
That was difficult.
I don't think any on your homework are quite that extensive.
You don't think?
I make no promises, man. It is me. Come on. There is one little tidbit that I would like to add to the set of notes. It is not on your homework, however, it is just useful information that will be used later. So you know how we did transformations before? Like
I think
shift left and shift right and shift up and shift down and fun stuff like that?
Yeah.
That can also be done with exponential functions. So if I have the function a to the x, so this is my parent or original function, a horizontal shift would be indicated by a value being added or subtracted from my x only. So this would look like a to the x plus k, and that plus k is up in the exponent with my x. If this k value is positive, so greater than 0, it would be a shift left. If that k value is less than 0, it would be a shift right. Okay, so the property still stays the same. It's just the placement of the value is different, or the number. We can also have a vertical shift then, which is k being added or subtracted to the entire function. So this would be a to the x and then plus k down at the same level as the A. And this one behaves just like our verticals did before. I should say this is a vertical shift. If K is greater than 0, we shift up. If K is less than 0, we shift down. And we shift however many units K is. And then the last little tidbit, which you do not have to write down, is that we use exponential functions to solve problems where we calculate compound interest. So this is not something that we're doing right this second, but it is an application that we will be working on. This is the most common application for exponential functions. So it is if you invest money into a bank account and your interest is compounded continuously, so every second of every day, the way we model that interest is using exponential functions like these, okay? So again, you don't have to write that, but that is helpful information that we will use later. So now your homework is on Canvas. Feel free to go ahead and get started with it and ask me questions as you have them. As always, I will stay on the Google call until the end of class. And then if you have questions outside of that, you can just email me.
You could give us a free day next class so you can have some time to make those